All right, this is a video solution to problem number 4 from exam 2. Okay, so in this problem, we're asking to look at a filter and implement it. And I already factored H of Z for you, so you see there's one, hopefully you identified one second order section, and then a subsequent first order section, and the total H of Z is H1 times H2. Alright, so what you're supposed to do is draw the cascade filter realization diagram for the cascaded system. Okay, so what I'm expecting you to be able to do is take a look at this transfer function, and then we know, okay, here is direct form 2. We just have that memorized. Here's the delay lines, here's the feedback A's, here's the B's. And so we just identify those. All right, so from the transfer function, you see here's A1, here's A2, and then the B's. That should actually be B0, B1, B2. Okay, is 1, 0.5, and 0.3. And then for the first order section, I changed them to alphas just so that the A's and the B's don't get confusing. So you have alpha is the feedback term, and then the two betas correspond to, essentially the B's. All right, so we've identified all the terms, and then we set this up into the diagram that you're supposed to know, okay? And so there you have it. That's a filter diagram for realizing this third order filter as a second order section cascaded with a first order section. Okay, in part B, you're supposed to write pseudocode. So the first thing you do is you identify the outputs of the summers. Okay, we already know that Y is an output. So we labeled W0, gamma, and B0. And then, because these are simply delay lines, W0, you have W1, then you have W2, and those are just delayed versions of each other. We'll fix that up with a delay line in a second. Okay, so from there, you look at each summer. So W0 has this term, minus A1 times W1, W2 times minus A2, and X. All those things are coming in to W0. Okay, and then gamma has three things coming in it. It's got B0 times W0. It's got B1 here, times W1, and B2 times W2, all come into the gamma line. And then finally, the last output, Y. Y is just beta 0. I'm sorry, we didn't get V0. V0, we have gamma coming into it, and we have minus alpha times V1. So looking at the diagrams where you get that. And then the last one, Y, is beta 0, beta 1. Sorry, beta 0 times V0, beta 1 times V1. And then this part is how you implement the delay lines. Remember, reverse order. That's all there is to it. Okay? So we've done this a lot, and hopefully we drilled that home, and you would know how to implement any kind of filter if you're given a transfer function.